Hey, good day, folks. Welcome to Paris Mind Academy, where we bring brilliance to every lesson. I'd like to welcome you back after watching now the previous video. I want to assume because it's the first video that you have to start with, where now we explain all the concept of oxidation numbers and all of that. If you haven't done so, please check my description below. I definitely put it there. Okay, I will put it there so that before you continue with this video, start into that video first, and then after having a better understanding of what is oxidation number and all of that, you can come back here because everything is going to be smooth and beautiful if you have already watched that previous video there off. Okay, so now let's move. Now remember, I did mention in the previous video that what we are dealing with is redox reaction, but I want us to now talk a little bit about oxidation number. But now in this video, we will now look in depth what exactly we were referring to when we talked about redox reaction. We will see the uniqueness of these types of reaction. Remember, you have dealt with acid and base reactions, okay? But now in acid and base reactions, you only dealt with the reaction of elements and all of that. But here we have to balance the charges, the electrons. Like, guys, it's unique. Without wasting any further time, let's just dive into it. Okay, what is redox reaction? Per definition, redox reaction, it is a reaction that involves, okay, a reaction that involves the transfer of electrons. Okay, it is a reaction that involves the transfer of electrons. This is the most definition that I like. Okay, when you explain what is redox reaction, this is the most definition that I like. And then the other person can say redox reaction is a reaction that always involves a change in oxidation number, which is always true. Okay, this is also true because remember we will talk a lot about oxidation number, and then we'll talk a lot now about electrons also. But preferably, I prefer you to use this one, okay? To use this one. All right. Now, we see we have redox reaction, but we don't know exactly where does the word redox come from, okay? The word redox come from now, the word redox, okay, comes from the word reduction. And then the word ox, okay, there's something that I did there. The word ox comes from the word oxidation. So it's basically oxidation, reduction, reaction. Can you see? It's oxidation, reduction, reaction. Basically, it's oxidation, reduction, reaction. But now we try to simplify this word to what? To redox. But when you call it in full, it's going to be oxidation, reduction, reaction. Okay, we start with this one, come there, and then say reaction. I think you might say, oh, Mpo is talking is China, man. No, are we China? We are still moving along. Redox reaction. Okay, when they say define oxidation, reduction, reaction, guys, it's still the same as redox reaction. Don't be confused. Okay, so now I want us to have the explanation of exactly what is reduction, what is oxidation. Okay, we will have a table where we now fully explain what is reduction, what is oxidation. Okay, I want us to have that beautiful summary of. I think my line is not necessarily straight. Okay, it's fine. Now I'm gonna settle for that. Now, what is reduction? Okay, what is reduction? Now, reduction in terms of electron transfer. Okay, in terms of electron transfer, we say reduction is gain of electron. I'm going to say reduction is gain of electrons. Okay, and then oxidation is going to be what? Loss of electrons. Whew. And then someone says, "Who? How am I gonna know reduction is gain of electrons, oxidation is loss of electrons?" Isn't there any analogy that maybe one might come with and say, "Okay, okay, guys, it's fine. I'll, 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 I'll just come with this." But now the fortunate part is that we do have an analogy that where we say for oxidation is loss of electrons, right? So you're gonna say oil rig. We use oil rig. What does oil rig help me with? Oil rig tells me that oxidation is loss. Oh, beautiful. And then reduction is gain. Oh, marvelous. Yes, I know, right? I know. Oil rig. Oxidation is loss, reduction is gain. Of what? Of electrons, of course. We'll just add that. Now, the examiner can say again, instead of explaining what is reduction in terms of electron transfer, explain what is redox, or rather, what is reduction, sorry, in terms of oxidation number. No. So we have two definitions per term. Yes, that's true. Reduction can be defined in terms of electron transfer or can be defined in terms of oxidation number. Why? Because we can also define redox in terms of electron transfer or in terms of oxidation number. So it makes sense. So what is reduction in terms of oxidation number? Remember, in oxidation number, we're talking about plus 2, 2 plus, I mean plus 2, plus 3, plus what? So what does the weight reduction, where do we take the weight reduction from? We take the weight reduction from reduce. Okay, when something is reduced, it's reduced. When we reduce, I reduce. You know what? You decrease. Okay, so it means now reduction is gonna be a decrease in oxidation number. Okay, because it is reduced. Okay, and then this does not apply to electron transfer. Okay, we don't say reduce, or when it is reduced, it loses electrons. No, for electrons, use oil rig for better, beautiful understanding. So it means if decrease in oxidation number, it is reduction. Oxidation, can you see it supports the word oxidation number? So it means they are being okay. Just say this is an increase in oxidation number, guys. This is in terms of electron transfer. Okay, this is in terms of electron transfer. Okay, now we have what we refer to as oxidizing agent and reducing agent. Okay, now first thing first, let's talk what is an agent. Okay, if you were to understand the word what is an agent, everything will be beautiful. Okay, you first need to understand what is an agent. If you're that particular someone who likes to watch the movies and what and what and what, an agent is something or someone that makes something to happen. Okay, when we are saying we are an agent, those who like to watch soccer, ne, we know that each and every player should have an agent. That agent makes transfers to happen. Okay, it makes now the transfer of a player from one team to another to happen. Also, those who are watching netball or NBA, I don't know what you call that, the basketball thingy. Each and every player has a what we refer to as an agent. What does an agent do? An agent is the one that negotiates the transfer. Okay, your transfer, whether if that team wants you, okay, whether they're gonna transfer you to that team so they're gonna lose you, or that when this team loses you, that other team is gonna gain you. Okay, so hence we are saying it is a transfer of electron. For argument's sake, if I were to make an example here, okay, let me return back here. If I have a compound A, B, okay, A and B. If electrons move from A to B, electrons, okay? If electrons move from A to E, what happens? What do we say? We say you lose electrons, okay? You lose electrons, and then this one will gain electrons. This is why what happens in a redox reaction. A redox reaction will always occur when there is a what? There is a transfer of electrons. When there is a transfer of electrons, it should always occur. Okay, this should always be the case. Okay, I hope that makes sense. I hope that makes sense. And then let's see. Now, an agent, if you are reduced, okay, if reduction occurs to you, it means now when, okay, if when you are reduced, it means you made the other particular person to be oxidized. Okay, if when you gained electrons, if you gained electrons, it means you made the other one to lose electrons. So it means when you're gonna be the what? You're gonna be the oxidizing agent. Okay, you're gonna be the oxidizing agent. Oxy agent. Okay, what now is an oxidizing agent? An oxidizing agent, it is a substance that is, okay, I'm going to say an oxidizing agent, it is a substance that is reduced, okay, or that loses electrons. I'm lying. That gains electrons. Why am I saying that? Please take note of this. I'm going to explain this again. If when you undergo reduction, if when you are reduced, it means you caused the other one to be oxidized. So you are an oxidizing agent. You cause the other one to undergo oxidization, whereas when you undergo what? Reduction. Okay. And remember, when you undergo reduction, it means when you gain electrons. So hence I'm saying an oxidizing agent is a substance that is reduced. Okay. And a substance that is reduced or a substance that gains electrons. So it means the one that undergoes oxidation is going to be what? Reducing agent. Not reduction agent, reducing agent. What is a reducing agent? It is a substance. So it has the ability to reduce others. So it means if it has the ability to reduce others, it wants to undergo what? Oxidation. So it is a substance that is oxidized or loses or uh, loses electrons. Guys, I hope this makes sense. I hope this is clear. I hope everything makes sense. Like, I hope so. I hope so. Not sure what's happening here. It does not want to work. Oh, oh, here it is. It does work. So, okay. So, I hope these terms now make sense. If they were to say, explain what is a reducing agent, just say, okay, a reducing agent, it makes the other one to undergo reduction. So iron is oxidized. So if it is oxidized, you will explain what you will say. It is a substance that is what is oxidized, lose electrons. So it is a substance that loses electrons. Easy peasy, peasy easy. So we say um, uh, oxidizing agent. Okay, ungwala hampi mpo. oxidizing agent is done what? Is reduced. And then reducing agent, what is this much? Is oxidized. Oxidized. All right. This now makes perfect sense. If an oxidizing agent, you make the other one to undergo oxidization because you are an agent that oxidizes others, you make the others to go oxidization, whereas when himself you want to go to undergo reduction. Again, yes, guys. Guys, this is beautiful. Now let's try to make a typical uh let's have an equation and see in this equation which one is reduced, which one is oxidized, and all of that. Okay, let's have an example. Okay, refer to the um, unbalanced. Okay, let me not state whether it's balanced or not. Refer to the equations below and state which element or compound undergoes reduction. Okay, which compound is reduced or oxidized? Oxidized. And explain why. All right. So now let's consider this example. It says refer to the equation below and state which element or compound is reduced or oxidized and explain. Oh, explain. Yes, explain, Paul. So let's consider now us having, okay, Mg plus O2 giving us 2MgO. Okay? Well, it's unbalanced. Actually, it's like this. So we can balance it, we cannot balance it, it's fine. Let me just try to balance that. Now, how do we find the redox reaction? So we need to interpret this in terms of redox. How? How will we see which one is reduced, which one is oxidized, which one is what, blah, 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 blah. On this one, I want you to use the definition of oxidation number, okay? Remember, on the last previous video, we explained that a pure element has an oxidation number of how much? Yes, 0. Again, remember a pure element has an oxidation number of how much? Of 0. So Mg is pure, it has an oxidation number of 0. O2, it is pure, it has an oxidation number of 0. But now, can you see MgO? It is pure. Yes, it is pure. The whole compound is pure, but Mg Mg now is no longer pure. Why? Because Mg, in this case, it has a total of how much? Remember, Mg, it is found in group 2, so it has an oxidation number of how much? Of 2 plus, and oxygen has a... Guys, when oxygen is represented like this, it is 0. But when it is in a compound, you need to give us its thingy. Okay, so oxygen has an oxidation number of how much? Of 2 minus. Okay, so we need to check, okay, what happens to Mg? Mg moved from MgO to Mg2 plus. So here there is an what? There is an increase in oxidation number. And we know per definition, an increase in oxidation number, it is what? Oxidation. Oxidation. Then let's look at oxygen. Oxygen moves from 0 to 2 minus. So there is a what? Decrease in oxidation number. What does the decrease in oxidation number tell us? That this, per definition, this it is reduction. Okay, guys, when you answer this question, which one is reduced, which one is oxidized, you always look at the left hand side. The left hand side is where you will find the one that is reduced as well as the one that is oxidized. This side will never give you the one that you will never use the right hand side to say whatever this element that is here is oxidized. That's a lie. Okay. So now when you answer this question, we're gonna say Mg is, can you see there is an increase in oxidation of Mg? So it is oxidized. Okay. Why? Why? The reason is okay, let me say it's oxidized to Mg2 plus. How do we know that? Its oxidation number increased from 0 to plus 2. This is how I will explain for what? For magnesium. This is how I will explain for what? For magnesium. Actually, let me write it down here so that it's going to be beautiful and more clear. Okay? I'm going to say Mg is oxidized. How do I know that? Its oxidation number increased from 0 to plus 2, not 2 plus 2. Okay? Okay? And now, remember, a substance that is reduced, or rather, a substance that is oxidized, it means it causes others to undergo what? Reduction. So it means Mg is a reducing agent. But I'm giving you all the information. Mg is a reducing agent. Okay? Okay? Yes. And then, when we look at O2, we're going to say O2 is reduced. How do we know that? Its oxidation number decreased from 0 to minus 2. Therefore, O2 is a what? If you are reduced, you are what kind of agent? Oxidizing agent. Guys, okay. I'll talk about that later on, not now. And then, yeah, guys, you saw that most. Now, guys, I want us to talk about 6 things. No? 6 things. I want us to talk about 6 things, fundamental 6 things. Okay? Write down the following. Okay, let me say use the equation below to write down the following. What are the following? Oxidized agent, mm, an element that is reduced or oxidized. Number two, oxidizing and reducing agent. Number three, reduction, half cell, and oxidation, half cell. I know I haven't mentioned anything of the half cell, but now I will mention it again. And then lastly, the net ionic equation. Okay, beautiful. Now let's look at that. Let's consider an example, Mg plus Mg plus zinc chloride to form as magnesium chloride plus zinc. Now we know the process that we are supposed to undergo to do again. First thing first, identify the oxidation number. I start with the easiest one. Mg, it is just a pure element. And then I come here. You still remember when I come here, what process do I use? Remember, if I have H2O, it means now this one here is for H plus and it's positive, and then the 2 is for oxygen minus. I'm just reversing the thing is. So it means here also this 2 is going to be for the zinc, and then the 1 is going to be for chlorine. And I know chlorine is negative unless acted with oxygen, and then it means this one is going to be plus. So this is minus plus. Okay, and then this is not balancing, guys. This is not balancing. We are just checking felt. And then chlorine is going to be 2 plus here and minus again. And then we will see. We will see what happens. Okay? We will see what happens. I forgot to mention something. That's fine. Now we see that Mg, Mg is a what? Mg is oxidized to Mg2 plus. Okay? Therefore, if it is oxidized, it means Mg. If you're oxidized, it means you caused the other one to be reduced. So it means you are what? Reducing agent. And when you check at zinc Cl plus, Cl2, zinc 2 plus went from 2 to 0. So which one was reduced between these two? So this is where people make mistake. Zn2 plus was reduced to Zn. Okay? So Zn2 plus is the one that is reduced to what? To zinc. So if they were to ask you which substance is reduced, it is not zinc. It is zinc 2 plus. Why? Because the zinc 2 plus is the one that had a decrease in oxidation number to zinc. Guys, that should sink. When I was zinc. By the way, therefore, Which one is a reducing agent? Zinc 2 plus, guys. The one that was reduced is going to be a what? Oxidizing agent. Why oxidizing agent? Because for it to undergo reduction, it needed to make the other reaction to undergo oxidization. Remember, for redox reactions to occur, we need oxidization and reduction occurring simultaneously. Guys, and then can you see that Cl2, the Cl2 is still, and it is minus and minus. So this is what we refer to as spectator ion. Let me say Cl minus is a spectator ion. This is very important because I never mentioned anything about it. But it is a spectator ion. What is a spectator ion? And how come did I not talk about it? I was supposed to talk about it. Yeah, I think somewhere here. So let me explain what is a spectator ion, by the way. Spectator ion, okay? It is an ion that does not experience a change in oxidation number. So if they ask you, why is nitrate? Okay. Oh, okay. By the way, these spectator ions are not included in net ionic equation. The one that we will be looking at, they are not included because they do not undergo any change. Now, we have answered this. The oxidized agent, the reduced, the oxidizing, an element that is oxidized, an element that is reduced, an oxidizing agent, and reducing, oxidizing agent and reducing agent. And then we are done with this. We are done with this. Now we need a reduction half cell. Guys, for reduction half cell, I want you to look at it like this. I'm going to rewrite the example. It's fine. I'm going to rewrite it. Or rather, let me just copy it. Let me just rather copy it. And then, so that things can be now easier for us. Okay. Guys, I know in your schools they will teach you how to use a table, but I will never do that. A table, you will use it next year, electrochemistry, when you're doing galvanic and electrolytic cell. For now, yes, I will show you how you use a table, but that's not my priority. I want you to understand the theory of chemistry of. Remember, for reduction half cell, let's start with the reduction half cell. How do I see my reduction half cell? Well, I check the one that is reduced. Which one is reduced? I know that zinc is reduced, so it undergoes reduction. And no, so I'm going to say, oh, so zinc 2 plus underwent reduction. Okay, how do we know that? We see there was a decrease in oxidation number. But now we need to rephrase back and say, okay, what does reduction mean in terms of electron transfer? Remember, we have what we refer to as oil rig. What does reduction mean in terms of electron transfer? We are saying reduction is gain. So reduction is gain. So it means zinc gained electrons. But the question is, how many electrons? Well, 2 electrons. Okay, 2 electrons. So zinc gained 2 electrons to form zinc 0. Actually, just say zinc 2 plus gained. Which one gained electrons, guys? It is this one. You start it like this. You always start it like this, guys. where you start to the reactant, from the reactant to the product. Zinc 2 plus plus something because it gained electrons. How many electrons we don't know. It formed just pure zinc. Again, so it means now if here it is 0, it tells you that the electrons that were there were 2 electrons. So that 2 electrons plus 2 protons, it gives you 0. What if it was we had x2 plus, then forming as x minus plus? So it tells you that you only had 1 electron. Okay, we only had 1 electron. Take note of that. And then we are done, like done, guys, done. When you have done this is reduction half cell. Let's consider oxidation half cell. Oxidation half cell, I'm gonna say Mg to Mg2 plus, it underwent oxidation. So Mg went to Mg2 plus. But the question is, according to oil rig or according to electron transfer, what is oxidation? We know that oxidation is loss of electron. So it means Mg lost electrons. How many electrons? 2, again, because it is 0 here. Lost 2 electrons. But we can't write the equation like this. We always write our electrons that are lost or gained with plus. So it means this will be Mg to what? To Mg2 plus plus 2 electrons. So these electrons are lost. Can you see? They are lost in the form of products. But now these ones are gained. Okay? So yes, the final answer is this one. Okay? The final answer is that one. Also here, the final answer is this one. So this is reduction half cell, and that one is oxidation half cell. Now we need to go to net ionic. Net ionic what? Equation. Well, how can I find my net ionic equation? Well, I need to add those two equations. Zinc 2 plus 2 electrons forming me zinc, and then I add it to what? To Mg forming me. Let me do it like this so that you do not get confused. Zinc, and then write an arrow here, Mg2 plus 2 electrons. Guys, on this part, what's important is that when you balance this part here, you should make sure that the number of electrons are the same on both reactions. I repeat, you should make sure that the number of electrons are the same for both. Can you see here the number of electrons? It is 2. This one, it is 2. So that's beautiful. So it means I just add everything, reactants to reactants, products to products. But now the 2 electrons and the 2 electrons, the reason we are balancing them so that they do what? They balance each other. So in this one, I'm left with what? Zinc 2 plus, okay, plus Mg forming me what? Zinc plus Mg2 plus. This is what we refer to as the net ionic equation. Okay? Now, you need to check, is it balanced now? Chemical balanced? Yes. Zinc, it is 1, it's 1. Yes. So, magnesium is 1, is 1. And then you need to make sure that the charges are balanced also. How many charges do I have here? I have 2 plus 0, it is 2. I have 0 plus 2, it is 2. Everything is balanced. Redox reaction, unlike acid and base reaction, redox reaction, we need to balance the elements and compound as well as their charge. Okay, now let me make the last example so that this will make sense. Let me show you how you can use your table. Where is that table? Let me copy a table. We're going to use table 4b, by the way. Table 4b. Table 4b. Copy that. And I'll just put it here. Okay, how do we use table 4b? Well, you need to consider your two reactants that we're looking at. You are looking at magnesium as well as zinc. So we're talking about magnesium moving from MgO to Mg2 plus. Okay, so you're gonna go to your standard of reduction table and look for Mg that forms Mg2 plus. Here it is. I just do this for now. And then I will look for what? Zinc 2 plus to zinc 0. Which one is that? Zinc 2 plus to zinc 0. Zinc. I don't like this because it is time consuming for me to be looking at zinc. I think it's down here. It's down here on table 4a. Okay, let me relax. Where's zinc, guys? If you have found zinc, unfortunately, oh, here is zinc. Ooh. So what I do is I do this. I draw my C table. Not my C table. I do my C method. So my C method says I start here, so I go that direction. And then I go like that, like that, like that, like that. What does this tell me? It tells me that this reaction, I'm going to take it from the left. I'm going to write it from the left to the right. What do I mean? I'm going to write it from Mg, forming me, I'm going to just use one arrow, forming me what? Mg2 plus 2 electrons. But this one, I'm going to write it from right to left. Can you see the arrow says I start here, I will go there. But on this one, says I start there, I go there. So on this one, it's going to be zinc 2 plus 2 electrons, forming me zinc. Oh, so which one undergoes oxidation? Which one undergoes reduction? You just check here. Here it is 0. This is 2 plus. So this one is an oxidation half cell. Which one undergoes reduction? It is this one from 2 plus to 0. This one, it is the reduction half cell. Let's confirm. Is it the same? Mg2 plus, Mg to Mg2 plus. Oxidation half cell. Can you see? Yes, it is. Reduction half cell. Yes, it is. So, yes, that's basically that. Okay, that's basically that. And then let me show you how you can use your table for that one. Let's consider this reaction. Let's consider this reaction Cr2O72 minus, because they like it a lot. Sn2 plus H plus, forming me Cr3 plus Sn4 plus H2O. Oh. Okay, guys, let's focus. Which ones are pure elements here? H2O. Okay, no, H2O, it is a compound. I want element. So there's no pure element again. So this is 2 plus. This is, okay, just HCr3 plus. And then, okay, let's come here. We know that hydrogen, it is plus 1, which is plus, and then oxygen is 2 minus. And then we need to come here. We need to find the oxidation number of Cr first. Okay, let's find the oxidation number of Cr. We're going to say there are 2 Crs plus 7, how many oxygens? 7 oxygens, and then the net, it is -2. You still remember? Go back to the previous video. So it's going to be 2 Cr is equal to -2 plus 14, which is 12, and then Cr is going to be plus 6. So if Cr, it is plus 6, oxygen, oxygen, yes, oxygen is still 2 minus. No, you are lying. You are lying, you are lying, you are lying, you are lying, you are lying. Well, I'm not lying. Yeah, I'm not lying. Check. 2 multiplied by 6, that's 14. And then 7 multiplied by -2. Oh, I'm lying. This is 12. This is 12, this is minus 14. 12 minus 14 is negative 2, yes. So it's fine. So, and then we can now check, okay, which one undergoes what? We can see that CR2 undergoes a reduction, okay? CR2 undergoes reduction. Why am I saying CR2 undergoes reduction? Because it is reduced. Okay, it is reduced from this one to that one. But when I write it, I won't just write CR2 reduced to CR3 plus. It is reduced from which compound? From this compound, all of this compound. Okay, so what we do is we're gonna say CR2O72 minus was reduced, all of it. Yeah, we know here oxygen remained constant, so it did not change again. So this one underwent reduction. So we know that when you undergo reduction, reduction is gain of electrons. So you gained electrons. But the question is, how many electrons? Well, first thing first, I need to balance. I need to balance the reaction. Can you see how many CR do I have here? I have 2 CRs. So I need to say this is 2 CR. And then I check the CR here. It is 2 multiplied by 3, which is 6. So it means I'm going to take just 6 electrons. 6 electrons. And then, but now, can you see it is balanced? Yes, we can see it is balanced. We need to balance the oxygen. We have oxygen in here, but we don't have oxygen here. So we're going to say CR, oxygen. Well, electrons, not really. So can you see that the CR here, remember initially it was this. And then we had 2 here. And on this side, we had 1. Oxygen, we have 7. On this side, we have 0. So I need to balance the CR by multiplying by 2. So I just do that, it's balanced. But now, can you see the oxygens are not balanced here? How do I balance oxygen? I balance oxygen by adding, remember this is 2. Add water to balance oxygen and add H plus to balance hydrogen. This is when I do it manually. Okay, yes. So I need to balance oxygen, so I need to add water on this side, okay? Water. But now when I add water, how many oxygen do I now have? I have 1, can you see? But I need how many oxygen? 7. So I need to multiply by 7. So I'm not going to multiply here by 7. But can you see when I multiply that by 7, the oxygens are now 7. But now I have added an element, which is hydrogen on this side. And how many hydrogens do I have on this side? It is 14. So it means I need to balance hydrogen on that side. But remember, to balance hydrogen, you need to add what? H. So how many H am I going to add? Plus 14 H plus. Okay? And remember the electrons. How many electrons do I need? Remember, it's going to be 2 multiplied by 3. Here it is 6. So it's going to be 6 electrons. Okay? So it's going to be 6 electrons. And then when it is 6 electrons like that, then I'm done. But what you can do is, you can say, let me go look for CR2O72 minus, that forms me CR3 plus on my table. And let me look at this one. We say this one undergoes reduction again. So when you check SN, it undergoes what? Oxidation. Because H plus, it is still H plus there, okay? So SN, it is straightforward, it undergoes oxidation. SN, 2 plus. Remember, oxidation is loss of electrons. So when I lose electron, I need to be 4 plus plus 2 electron. Okay? And then how do I know? I mean, you can go to your table and say, I'm gonna erase this. I'm gonna use my seed method again. I'm gonna look for CR, blah blah blah, the longest CR. The CR, I'm gonna look for CR and SN. Can you see I have SN here, but this gives me SN pure. So I need SN that forms me SN 4 plus and SN 2 plus. Here it is. SN 2 plus and SN 4 plus. Can you see 2 plus and 4 plus? So that is the SN I want. And then I'm going to look at CR3. So CR207, that gives me CR3. Can you see? It gives me CR3. So I'm going to also look at this one. Remember when I use my method, it says what? It says C. So it means as I go there, 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 I go there. It says this one, you're going to write it from left to right, meaning it's going to be SN2 plus, forming you SN4 plus 2 electrons. Is it oxidation or reduction? This one undergoes oxidation. Why? Oxidation number increased from 2 plus to 4 plus. So this is oxidation half cell. Is it true? Yes. This is oxidation half cell. Remember, this is reduction half cell. So let's see if it's correct now. Cr2072 minus plus 14H plus 6E. We write it going to that side. So I'm going to write it just like this. Plus 7H2O. Is it the same as the one that I wrote here? Yes. Cr2072 minus plus 6 electrons plus 14 hydrogen atoms. H plus hydronium ions plus 2Cr3 plus 7 blah 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 blah. You see it's the same. So you can use your reduction table or you can just manually do this. So I know this is reduction half cell and that is what. And then I will need to write down the what? The net ionic. Okay. When I write the net ionic, I prefer saying, let me write it like this. And then say SN4 plus 2 electrons. This is oxidation half cell, by the way. And then this is very important. Remember when I want to write my net, what should happen? Let me write this at least below here so that it does not have any confusion. Remember what should happen? The number of electrons should balance. So here I have 6 electrons, here I have 2 electrons. So it means I need to multiply this equation by 3 so that I have how much? 6 electrons. So when I multiply this by 3, it's going to be, I'm going to rewrite it again. It's going to be Cr, let me use a black pen, 2072 minus plus 6 electrons plus 14 H plus to form us 2Cr3 plus 7H2O and then then I have multiplied by 3, it's going to be 3SN2 plus forming me SN4 plus 6 electrons. And then I can now beautifully find my net. Why? Because this one and this one cancels. And then I write everything from here. So I'm going to say it is Cr2072. By the way, the order does not matter. Whether you write this one, as long as the reactants are the same as the product. So as long as the reactants are the reactants, the product for the product. And then forming me 2Cr3 plus 7 water molecules plus SN4 plus. I need to make sure that everything is balanced. SN. Oh, I think I forgot to multiply 3 here. So it is 3 SN4 plus. Is SN balanced? SN here 3, good. Hydrogen 14 here, good. Cr2 there, good. Then oxygen 7 good. Everything is fine. Then let's check. Are the ions balanced? Are the charges balanced? -2 plus 1. Okay. This is -2 plus 14 multiplied by this, it is 14 plus 3 multiplied by that, it is 6. Is it equal to now 2 multiplied by this? It is 6. And then 7, okay, it's just, this is pure. And then 3 multiplied by 4, it is 12. And then let's see here. I have 20 minus this is 18. And then this is 18. This is balanced. So this is balanced. So that's how we balance it. And sometimes you might encounter something like this. Let's say you have x to n 2 plus 2 electrons giving you x. And then you have the other one that is y minus y plus forming y3. Okay. Let me do this again. And then can you see this is a reduction what? So let's say this is oxidation. This is oxidation half cell. How do I know oxidation number increased from 2 plus to this one? You are lying, it decreased. And then this one, it is from 0 to this is oxidation half cell. And then now what's important is that for now, for us to get the net, we need to make sure that the electrons are equal. Again, but can you see this one is 2, this one is 3? So there's no beautiful factor. So if there is no beautiful factor, you're going to multiply this by 3, multiply by 2, their respective coefficient, just vice versa. And then this will be 2cx plus 6 electron, giving me, okay, this is 3x. And then this is going to be 2y, giving me 2y plus 3, 6 marker, 6 electrons. And then here, this is the reactance, is going to subtract this one. And then I'm going to be left with what? I'm going to be left with 3x plus y. Okay, I left my 2 plus here. So it's going to be 3x 2 plus. And then gives me 3x plus 2y 3 plus. The charges are balancing here. This will be 3 plus. And then is my y balanced? Y it is 2, y it is 2, x it is 2, x it is 2. And then is my charge balanced? This it is, remember this is 2 plus. So it's going to be 3 multiplied by 2, it is 6 plus 6. And then this is 0 is equal to, this is 0 plus 2 multiplied by 3 is 6. Can you see this balanced? So yeah, thank you very much, folks. That's all I have for you for this redox reaction. And hopefully you enjoyed from oxidation number video up to this one. So yeah, we'll just have follow up when now we do what question papers. So thank you very much, folks. Until we meet again on other topics. Okay, thank you very much. Thank you again for supporting my channel, and yeah.